Hey everybody, welcome to section 5. This is our last section of notes for this unit. So your notes are due today after you complete this video. So we're wrapping up our unit on the Renaissance and Reformation with the scientific revolution. Now this is the final break from Europe's medieval past moving into the modern era, and it was new thinkings about the physical universe around them. Now, one of the biggest ones being from Copernicus, who challenged ancient astronomy. Now, he was Polish and established a heliocentric theory. Excuse me. Remember, we've talked about that previously. That is a sun-centered model of the universe. Now, this went directly against the ideas of Ptolemy and Aristotle, classical thinkers that had said, no, the Earth is the center of the solar system. And he got a lot of negative publicity from this. People were really upset with him over this. You also have Tycho Brahe, a Danish astronomer who provided evidence and use of an observatory to further add to this heliocentric theory, and Johannes Kepler, who used Brahe's data to support Copernicus. Now, he also believed that the universe and our solar system, you weren't going around in a perfect circle. It was more of an ellipse or an oval-shaped orbit, which is actually still the basis in modern-day astronomy. Now, Galileo Galilei, probably someone you've heard about before, and his quote-unquote heresies. Now, he invented the telescope, and his observations contradicted ancient views, church teachings. He was Inquisition, and he said, well, and yet it moves. And a lot of his ideas were viewed as very radical at the time. People really didn't like Galileo because he was saying things that went against things that were their core values. Another big thing that came out of this was a new scientific method, inspired by Plato, a student of Socrates and teacher of Aristotle. Remember, we talked about him last semester. And he encouraged a look beyond appearance, and that math was the key to truth, saying, I have hardly ever known a mathematician who was capable of reasoning. Now, this new method determined how truth was determined. And typically it established the end of the investigation, rejected Aristotle's teachings, and challenged the church, essentially saying the physical world was made to fit teaching. It was the scientific method's job to explain the world around them, not the church, not religion, but science. Now, another revolutionary thinker we need to talk about is Sir Francis Bacon. Now, he came up with the idea of an experiment, doing observation, and practical technologies that made life better. He went on saying that knowledge is power and power is knowledge. He believed that the best way to understand things was to simply just look, observe the world around you, determine if those things were actually things that you could control, or experiment on to see how they react. We also have René Descartes, who advanced human reason, provable knowledge, and the idea of doubt, things you couldn't question. He was a rational thinking being and said, cogito ergo sum. I don't believe you need to write that down, and which translates to, I think, therefore I am. I'm sure you all have heard that phrase before. Now, the scientific method, y'all have seen this before. I would assume you all have seen this in science by now. It's a step-by-step process of discovery based on observation and experimentation. I'm not going to go through the whole scientific method. Y'all know it. I would assume, and I would believe you guys have gone over this enough times in science class that I don't need to do that. So let's talk about some breakthroughs in medicine. Andreas Vesalius, who's inspired by Galen, discovered errors in human anatomy, and he decided to provide accurate and detailed human anatomy by studying autopsies and the human body itself. Ambrose Pare was the father of modern surgery and proceeded to give out ointments to prevent infection, things like your very first, things like Neosporin, like early versions of that. And then these are some of the surgical tools that he would have used. You also have William Harvey, who described the circulation of blood, understanding our circulatory system, and Anton van Leeuwenhoek, who perfected the microscope. And he was the first human to see cells and microorganisms. This is actually his first microscope, circa the late 1600s. We also have Robert Boyle, who is the father of the field of chemistry, aka alchemy. Now, This is the process of manipulating metals and acids. And this is when individual elements are sometimes combined to make chemical compounds. They also studied the effect of pressure and temperature on gases. This is Sir Boyle and Boyle's law, which you'll learn about in science. And for our final slide this unit, we're going to talk about Isaac Newton, whose idea of gravity, a single force that keeps planets in their orbits around the sun, aka the apple, as well as the laws of motion and mechanics. And that nature follows uniform laws, and motion is measured and described with math, specifically through a process known as calculus, or math used to explain Newton's laws. You've probably heard of Newton's 3 laws before, by far the third law being the most famous. For every action, there's an equal and opposite reaction. All right, that is it for your notes for today. So go and turn your notes in, start working on your review guide. Your test is just a few class periods away. I'll see y'all next time. Bye, everyone.